Welcome back. In this lesson, I want to quickly give you a high-level overview of DNS, the Domain Name System. DNS is probably one of the most important supportive services to understand. It's used extensively within AWS from an infrastructure perspective. It's also used inside other cloud platforms as well as most on-premises and internet-connected systems. So let's dive in and have a look. At its heart, DNS is a discovery service. It's how systems are discovered on the internet and often in private networks. It translates the information which machines need to and from informations which humans need. When using, say, Amazon.com, you might access it using www.amazon.com. But this isn't what your computer uses. That requires IP addresses. And so one function of DNS is to find the IP address for a given domain name. For example, www.amazon.com. Now, there are two crucial things to realize about DNS and its requirements. Because of the number of services on the internet and on private networks, and because of the importance of DNS, it's actually a huge database and it has to be distributed and resilient. To give you an idea of the scale, there are almost 4.3 billion IP version 4 addresses. If each of them had one or more DNS names associated with it, that database alone would be unthinkable in scale. But there are even more IP version 6 addresses. This many. DNS has to accommodate all that information and do it in a way that's distributed. So let's explore that. When you use your laptop to browse to www.amazon.com, from your perspective, it just loads. But that's a massive abstraction and simplification. Computers don't work with domain names. For your laptop to communicate to the www.amazon.com web server, it uses IP addresses. How this conversion happens is transparent to you, and that's because either your laptop or other device is communicating directly to the DNS system, or it's been configured to talk to a DNS resolver server on your behalf, and potentially this resolver server is running within your internet provider or on your internet router. DNS is a huge-scale database. It's distributed and it's global, but somewhere in that global platform is one piece of information, one single database, which has the information in it that we need to convert between the name and the IP address. So in this example, Amazon.com. Now that database, that piece of information that we're looking for, is called a zone, and the way that that zone is stored is often referred to as a zone file. And somewhere on the internet is one zone file for Amazon.com. Now that Amazon.com zone file has a record inside it, a DNS record, which links the name, www, and the IP address that your laptop needs to communicate with that website. This zone file is hosted by a DNS server that's known as a name server, or NS for short. So if you can query this zone for the record www.amazon.com and then use the result of that query, which is an IP address, your laptop can communicate with the web server. This zone file could be located anywhere on potentially one or two out of millions of DNS name servers. So one of the core pieces of functionality that DNS provides is it allows a DNS resolver server, which is sitting either on your internet router or in your internet provider, to find this zone, and once we've located it, we can query it, get the result, and use that result to access the website. And DNS does this in a way that's distributed, resilient, and hugely scalable. Let's quickly summarize the terms that we've learned so far in this lesson. Knowing these and remembering them are really important. Firstly, we have the DNS client. And the DNS client refers to the device or thing which wants the data that DNS has. So it wants the IP address for Amazon.com. And generally the DNS client is a piece of software running inside the operating system on a device that you use. So a laptop, a phone, a tablet, or a PC. Next, we've got a DNS resolver, and that could be a piece of software running also on the DNS client, so your laptop, PC, tablet, or it could be a separate server running inside your internet router, or a physical server running inside your internet provider. And it's the DNS resolver that queries the DNS system on your behalf. So generally the DNS client talks to the DNS resolver and it asks the DNS resolver to query DNS on its behalf. Next, we've got a DNS zone, and a DNS zone is part of the global DNS data. For example, Amazon.com, Netflix.com, or my own domain, Cantrell.io, they're all examples of zones, and they live inside the DNS system. A zone file is how the data for that zone is physically stored. So there's going to be a zone file for Amazon.com, for Netflix.com, and for Cantrell.io. So if I talk about a DNS zone, I refer to what the data is, its substance. If I talk about a zone file, I'm talking about how physically that data is stored. And then lastly, we have a name server, or a DNS name server. This is the server which hosts these zone files. So the point that we need to get to when using DNS is to find the name server which hosts a particular zone file, and then query that name server for a record that is in that zone file. That's the job of DNS. So the DNS resolver server needs to locate the correct name server for a given zone, query that name server, retrieve the information it needs, and then pass it back to the DNS client. That's the flow of DNS. Now, DNS is distributed. The data is stored in zone files, and those zone files are stored on name servers globally. DNS has to have a starting point, and that point is the DNS root. DNS is structured like a tree, specifically an upside-down tree, and the DNS root is at the top of this upside-down tree. It's really important for you to understand what the DNS root is. As the starting point of DNS, it's critically important to how DNS functions, but also if you understand how the root works, you're well on your way to understanding DNS. DNS names that you type into your browser look something like this. They're all read right to left, and they have multiple parts separated by periods. Notice how I've highlighted the rightmost period in pink. That's the root. You might notice that when you use DNS names in your browser, that period isn't there, and that's true. If you don't type it, your browser assumes it's there and adds it invisibly. If you explicitly type it, so if I type www.netflix.com or www.amazon.com, both of these will work because the browser adds this regardless of whether you type it or not. This is where a computer starts reading the DNS name. It represents the root of DNS. The DNS root, also known as the DNS root zone, occupies this topmost point of DNS, and like any other part of DNS, it's just a database. The DNS root is hosted on 13 special name servers known as the root servers. The root servers are operated by 12 different large global companies or organizations. It's really important to understand at this stage that these organizations only manage the root servers themselves, not the root zone database. Now, these aren't really 13 servers. Each root server can be a cluster of servers distributed globally, but it's represented by one entity, each of which has a letter from A to M, and each of these is managed by a different organization, with the exception of VeriSign, who manages 2 of these servers. These servers are the entry point, and you need to understand how your local laptop or desktop finds these root servers. Well, generally, your laptop will use a DNS resolver server that's generally located within your internet router or internet provider. The vendor of this operating system, if this is Windows, it would be Microsoft. If it's Linux, it would be the OS maintaining group. But in either case, they supply what's known as the root hints or a root hints file. Now this root hints file is essentially just a list of these root servers, so it's a pointer to the DNS root servers. And this is an example of how this root hints file looks, and I've included a link to it in the lesson text. So step 1 is that your DNS client asks a DNS resolver for the IP address of a given DNS name. In this example, www.amazon.com. Step 2 is that using this root hints file, the DNS resolver communicates with one or more of the root servers to access the root zone and begin the process of finding the IP address. Now, the root zone is managed by an organization called IANA, the Internet Assigned Numbers Authority. It's their job to manage the contents of this root zone. This is a separate job from managing the root servers which host the root zone. IANA, therefore, are essentially in charge of the DNS system because they control the root zone. Now, DNS is a system which is built on trust. At the start of the process, the only thing that your laptop trusts in the DNS system is this root zone, because it's been told to, either directly via the root hints file, or because it's been told to trust a DNS resolver server, which itself trusts DNS because of the root hints file. Okay, so this is the end of part 1 of this lesson. It was getting a little bit on the long side, and so I wanted to add a break. It's an opportunity just to take a rest or grab a coffee. Part 2 will be continuing immediately from the end of part 1. So go ahead, complete the video, and when you're ready, join me in part 2.